Okay, welcome back. In this presentation, we're going to be learning about GPS. Here we go. The aim: to understand and effectively use GPS for VFR navigation. So what we like to do, we're going to be talking about the G1000 primarily throughout this video, but then also the Garmin 430. Essentially the same things apply, they're just slightly different, but we're just getting the concepts, the basic ideas down here. What you'll learn: we're going to learn about the global navigation system, position determination. How does the GPS know where we're at? GPS use for VFR flight, how are we going to use that? Basic GPS manipulation and airmanship, as well as, like many other videos, common errors, some of the things that students are doing, and then the correction for those. The global navigation satellite system. This picture shows, a satellite with this bubble around, and that's sort of a good visualization of it. And then how we determine where we are at is when a bunch of these bubbles overlap and intersect each other, and then that overlapping is sort of how the GPS knows where it's at. So this is sort of just a visualization of the satellites, and then we're going to talk specifically about how it does that. So the global navigation satellite system is satellite based. There are some ground stations, but for the most part it is just satellite based. It uses high frequency signals containing time information, and from this time stamp information we can determine distance. The GPS units is going to receive multiple signals, enabling it to determine its position. So we need multiple signals, we compare those, and that's going to give us our position via triangulation. Alright, here we have the Navstar satellite. So we have essentially two functions. We have the satellite and then our receiver. So the satellite transmits this random code of ones and zeros with a timestamp. Then our receiver picks that same code up, and then it has a difference in time. So when the satellite sends that signal to whenever our GPS receives it, there's a difference in time. And that difference of time times the speed of light equals a distance information. Okay, so just trying to give you the nuts and bolts about how does this even happen. Okay. Now we'll see that we have here 3 satellites continuously send signals, and think of the codes as being ones and zeros. So we can see that this satellite, it's sending its code with a timestamp, this one and this one, and then our receiver is going to decrypt those signals separately. We'll talk more about that in just a minute. So then we go back, we have all these satellites up there, and there's different satellite systems. Today there's 3. We have Navstar, GLONASS, the Russian system, and Galileo, the European system. Alright, the Navstar has 30 satellites operating since 1974 and globally since 92, operated by the U.S. Department of Defense. So Navstar is the U.S. system. The GLONASS and Galileo both have 30, 18 operational for Russia. The Galileo has 30, that's in Europe. Note, Garmin G1000 is a US GPS-based system. Position determination. So, like I said before, we determine our position by this overlapping of the signals. For example, one satellite, it thinks I'm here, the other satellite here, and then they start intersecting each other, and that's how we determine our position. So we need a minimum of 4 satellites to determine a 3-dimensional position. So left, right, and then up or down. If altitude information can be derived from a baro altimeter, 3 satellites will be enough. RAIM. RAIM is a term we're going to hear when we're talking about GPS. It stands for Receiver Autonomous Integrity Monitoring. We're going to learn a little bit about that. We can see it here. We start first, we're at the aux page 3. And we get there by using this FMS knob over here. So it's the big knob will get us over to aux, and then the little knob over here to 3. And then we see in this section right here, RAIM prediction. So we could push this button, we'll scroll over and we get over here to compute RAIM, and then the GPS will compute its RAIM by itself. So we're going to learn more about what is RAIM now. Receiver Autonomous Integrity Monitoring of the GPS for Aviation Applications. A way that I describe it to students is RAIM, receiver, so our GPS receiver, autonomous, which means by itself. So our GPS receiver by itself can integrity monitoring. It can monitor the integrity of these signals. And then if one of these signals doesn't have good integrity, if it's not right, for example, we have 3 signals telling me that we're here, and then this signal tells me I'm over here. Well, that's not good integrity, so then it'll disregard that. So RAIM, we need a minimum of 5 visible satellites. The RAIM function continuously checks the position solution for those different satellites. If all the solutions do not indicate the same, there must be a fault and the RAIM warning is given. So then, I kind of already just talked about this. This fault detection and exclusion is that part of the GPS that will separate that signal out for us. So we need a minimum of 6 satellites now. So if we go back, what do we need for a 3D position? We need 3 plus baro altimeter. We need 5 for RAIM, 6 for fault detection and exclusion, and that's because we need to be able to take one and then throw it away, which will bring us back to 5, which is what we need for RAIM. Okay, so fault detection, we need 6 now, and that will be to exclude that bad satellite, allowing for nav function to continue without interruption. Because if we don't have 6 satellites and we have, say, 4, and then we boot one of them off, well, now we no longer have enough satellites to maintain our 3D position, and we'll have to revert to standard navigation, VOR, outside visual references, that thing. So RAIM failure enunciate. What's it going to look like when we have a RAIM failure? The RAIM will give a position error when we exceed certain limits. That's going to be if we're in the en route environment. If we're more than 2 miles from where we're supposed to be, we'll get a RAIM enunciation. 1 mile if we're in the terminal area, and 3 mile or 0.3 if we're on an approach. What we're talking about here is that at different phases the signal needs to be more accurate, and if it's not in that accuracy, we're going to get this RAIM failure. Typically what we'll see is RAIM unavailable, and that's going to be a message that we get on the G1000 or a 430, and it's going to say that RAIM's not available from just not available, or from the final approach fix to missed approach point. Position error, that means the RAIM has determined GPS position is in error. Okay, when we get that, the GPS is flagged, system no longer provides GPS guidance, so it's no good anymore, and then I'm going to show you what that looks like here in a second. Alright, RMP. So I was just talking about that in different phases we have different levels of performance, and here's a visualization of that. So RMP, required navigation performance. In different phases, meaning we're en route and when we're closer to the airport, we need higher accuracy. And so we'll start here at the bottom. We depart our airport, we're in this terminal mode. Then we move into the departure, en route, arrival. So when we're close to the airport, it's going to be a 0.3. When we're departing, it goes to a 1, and then a 2 miles en route. And then here we see it. So what does that mean? It means that if we're inside, the airplane's inside here, we're not going to get a RAIM message. But if the airplane starts to be outside of this left or right lateral limit, then we're going to get that message, And then we know, hey, the closer we get to the airport, the GPS switches its tolerances and gets tighter and tighter. That's more, if you think about it, it's not a big deal for us on VFR, but when we transition over to the instrument, we need to have that higher accuracy when we're flying instrument approaches. So just sort of think about that's the reason why these things exist. RAIM failure annunciation. So in all three cases, we get a RAIM failure message. We need to switch to conventional navigation, which is going to be, for us, using our flight plan and looking outside to our visual reference points, or we could use our VORs. If we're on an approach, we'll perform a go-around and prepare for a conventional approach. Okay, this is what it's going to look like. Right here, this magenta needle, it doesn't have a course bar or a CDI. So that means, hey, it doesn't work. And then so GPS en route, but then here we have INTEG. And here it's zoomed in, INTEG, integrity. So note the AIRMANSHIP utilizes GPS input during normal operation. So on the G1000, our heading indicator, AIRMANSHIP, Attitude Heading Reference System. Our AIRMANSHIP uses GPS for it. So if we don't get it, this is going to be one level, but it's just other things are affected, including our DG. If you notice also, here we have NOR 330, but on this one they all went away. So we lost our GG because our GPS has been degraded. Doesn't happen often, but we need to understand what it would look like if it did happen. AIRMANSHIP, Attitude Heading Reference System, operation may be degraded if GPS signals are not present. Direct to. Now we're going to get into using the GPS for VFR. So direct to, definitely the most common thing that we're going to do. We're going to pop up, we're flying, hey, I'm going to go to this airport, we press direct and we're going to head to there. So the direct to, any waypoint found in the G1000 menus can be used for the direct to navigating, and those are found in our nearest page, waypoint pages, and our flight plans. We go into those and then we just highlight them, press direct, and we'll begin go. So we press the knob, the cursor lights up, we'll move that cursor with our outer knob over the desired waypoint, and we'll press direct and then head to there. G1000 provides nav guidance to the selected destination until the direct to is either replaced with a new direct to, or a flight plan is canceled, or when the G1000's powered off. So it's always going to stay in there until we essentially tell it not to. I'm going to be giving you some videos. I'm going to get into a G1000 trainer and show you these, but I just want you to have sort of the basic steps in mind before I show you the video. Alright, canceling direct to. If we want to cancel it, we're going to press the key to display the direct to window. So we'll press direct button. Alright, that page will come up, and then we'll press menu, which is right beside it, and then it'll say cancel direct to nav, and then we'll press enter to clear it out. Don't worry, we're going to show you a video. If a flight plan is still active, the G1000 resumes navigating along that flight plan to the closest leg that we have. Now we're going to get into a video. I'm going to show you those steps, and then it'll make a lot better sense to you. Alright, so the direct to feature, I'm going to show you three ways that we use the direct function of the G1000. First, the primary way, you're going to just hit the direct button. You get a window pops up. We're going to come down here. We have an outer knob and an inner knob. So we'll first use the inner knob. Alright, select K, and then I'm going to go to Dayton, Ohio, D-A-Y. So K, D, we use the inner knob. Now I'll go back here to the outer knob, switch it over, A, outer knob, switch it over, and then we go back in this direction, get to Y. Alright, I see Dayton, Ohio, Cox, that's what I want. We'll press enter. Activate, it's basically asking, are you sure? We'll press enter, and then we see we are going direct to KDAY. It's a distance of 155 miles on a bearing of 090. I look down here, that makes sense. All right, the other way that we're going to use it, we'll have a flight plan. You could go into the flight plan. I already have a few points programmed in here. So we could use our outer knob, select whatever waypoint we want. So we can go down here to KOSU, Ohio State Airport. I selected it. Now I want to go direct. So I'll press the direct key again. Columbus, Ohio State. Okay. And then we have some information we can make sure. It's a bearing of 087. Does that make sense? It does. 208 miles. That makes sense also. Press enter. It's saying activate. Are you sure? Yeah. We'll press it again. And then now we see direct KOSU up at the top, a distance of 207 miles and a bearing of 087. Okay. And the third way we'll use direct feature will be with nearest. So there's a soft key down here. We press that, and a list of airports pops up, and these are nearest airports, so the closest ones by. So the closest one we have is 8 miles away, 9 miles away, 17 miles away. So maybe I don't like this airport, it's not big enough for what I want to do or have the services I want, so we'll select this one. Again, now we'll press direct. All right, Paris, Illinois, Edgar County. Okay, enter. All right, activate or are you sure? We'll press enter again, and then there we see that we have it going on. I have the autopilot hooked up to GPS, so we're heading there right now. So those are the three ways. Now, what if we made a mistake? Like this last airport, I didn't really want to go there, even though it asked me, are you sure? And I pressed enter. We got a little excited. How do we cancel that? So we just go back here to the direct, and we see that one. Hey, I didn't want that one. We'll press menu. Here it says cancel direct to nav. I'll go ahead and press enter. And then now it reverted back to my flight plan. So we go here to my flight plan. I can see it has me I-17 going to KOSU. So we want to go to I-17, which is Pickle Hartsel Field. We'll go up to it. Now I need to press direct. Pickle Hartsel. Enter. Are you sure? Yes. And then now I see up here on my display direct I-17, and I got my GPS or my autopilot's heading there now. And so those are the three main ways. We have just the direct to button. We could smash in whatever airport or waypoint that we want to go to. Then there's the flight plan feature and the nearest feature. And then if we make a mistake, we want to do a cancel, we press direct. That last point that we entered will pop up. Press menu. Do you want to cancel it? Enter, enter, and then that's how we do it. Okay, cool. Flight plans. All right. We're going to enter the sequence of waypoints for our flight plan in chronological order. So I want to go here, 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 here. So we'll enter it in the order that we want to go. A note, a new waypoint is entered above the cursor line. So if we have a series of points, I put the cursor at this point just above it, and then I enter in a point, it's going to be inserted above where it's flashing. Again, we're going to show a video of me entering in a flight plan so you see it. All right, then also we'll see removing a waypoint. To remove a waypoint, a DP, departure procedure, STAR, standard terminal arrival procedure, an approach, or as we're talking about here, go, a direct go to. We're going to put the cursor on the point or procedure we want to remove, and then remove it. I think it's press clear and then OK. Here we'll check it out. Flight plans. So how are you going to enter a flight plan? We come over, press the flight plan button. We see this page come up, this big page. It's empty right now. What we do is we come down, push the front of this FMS knob. We see this line highlighted, and then we're going to enter our points that we want to travel through in chronological order, starting from where we're at. So in this example, I'm going to pretend like I'm actually on the ground at I-17, which is Pickle Hartsel Field. So let me go ahead and put that first point in. So that's where I'm at, and then I'm going to sequence my waypoints in chronological order after that. Alright, so I have the line highlighted. I'll go to this inner knob. This other window pops up, but that's where I'm going to enter in the points. So it's not K, it's I. Big knob, it goes over. I'm going to go to the left because the numbers are on that side. Big knob over, little knob 7. I see Piqua Hartselle in Piqua, Ohio. Yeah, that's what I want. I press enter and then that inputs it there. Now the next waypoint that I want to go to, we'll say, is Dayton Airport. So I'll use the little knob. I move it over. This waypoint box comes up. I put in K, big knob, go over, DAY. See there, big knob goes over, A, big knob over, and I'm going to go to the left because it's a shorter distance to get around the alphabet one way or the other. So I'm going to go left. I'm going to get to Y faster. You don't have to do this, just saying. And then that's the airport I want to go to. Enter. So there I have a flight plan set up. That's a real simple flight plan. But maybe I wanted to, or I forgot to appoint, and I want to add a point into my flight plan. What I need to do is I want to add a point in between I-17 and Dayton. So I'm going to go up here and select this line here, and then when I enter a point now, it's going to go above that. So let's enter in the Dayton VOR. Say that's a VOR I want to fly over on my way to Dayton from Piqua. So what I'll do is, and now I'll go small knob over, and the Dayton VOR is DQN. Big knob, move it over. Q is toward the end over here, so I'm going to go left. Big knob comes over, and then I'm going to select N. Okay, Dayton, Ohio. I see the VOR symbol right there. That's what I want. And then we also see it right down here. So DQN. Does that make sense? Sure does. Enter. And then now it put it up there. And so since I wasn't already actively going to a point, now I need to start. So what we want to do is go back up to this first waypoint, and now press direct, enter, and activate. So then now we could see here what's going to happen. We're going to go first, we're going to start from this I-17, then the next one we're going to go to is Dayton VOR, and then Dayton. And we could see it over here on this point. Right now I'm actually flying, so I'm flying toward Piqua, DQN, and then should be able to move this over. And then moving our selector, we could sequence through these points. Oop, didn't want to do that. Go back up here. If you do something like that, so I accidentally went over there, I just pressed clear, and then it moved it back. So anyway, what I'm trying to show you is that if I move this cursor, whatever I'm highlighted at, it's sort of lagging behind now, but whatever I highlight, that'll be it'll allow us to look at that point. Now if we want to cancel or remove a waypoint, all we have to do is highlight it. So I don't want the DQN, so I go up there, I highlight it, I press clear, remove DQN, I'll press OK, so I'll just press enter. And then now that's gone from our flight plan. We're going to go from our present position to I-17, then to Dayton. Okay, frequency tuning. We want to tune a VOR, a nav aid frequency, to help us along our route of flight. When we're using the G1000 for that, when we're loading or activating a VOR or an ILS approach, so this is in the IFR world, but if we were loading those, frequencies are automatically tuned. I know that's not a problem with us now, but we'll learn it in the active field of nav1. So when we load those approaches, there's an auto tune feature. It's not going to happen to us in VFR, but Anyway, if we're navigating on the GPS, the CDI should be set to GPS, which is the magenta needle. It is loaded in the standby field of the active CDI mode of nav1 or nav2. What I'm going to do is I'm just going to show you how we're going to use the VOR and the GPS for tuning and navigating. Okay, frequency tuning with the G1000. What we're going to do is start in the top left corner. I see my nav1, nav2. This area right here is the active frequencies, and then the ones on the left are standby. And what we do is we go down here. This says nav. I'm going to push the front of this, and then that's going to move my box from the top to the bottom. So there we go. I want to tune a frequency in here on nav1. A nearby VOR is the Terre Haute VOR, so what I do is it's 115.3. I start with the outer knob, and I'm going to turn it to 115. We'll go to the inner knob, 0.3, and then now we go to this button. It switches it over, and we see here 115.3, and then there's the auto ID feature. TTH is the Terre Haute VOR. Okay, good. That works for us. And then we go down here, and I've already have it set up. So this is part of the PFD. Go in here, PFD. This is called the bearing 1 pointer. So we have bearing 1. It's on GPS, ADF, VOR. That's what I want it on. And then the DME is set on the nav1, which matches it. So then it's saying here to me I'm 25 miles away from the Terre Haute VOR. Okay, but then I see, let me go back, I see this CDI is on GPS right now, the magenta, so we move it over. We want to use the VOR. Here it says VOR 1, green needles. Then what we could do is we go over here to this button. It's like this triangle, and we just push it, and that centers the VOR. And now I know, okay, the VOR is over here to the south, and if we wanted to go direct to it, that's what we do. Alright, GPS CDI. Some more of this frequency tuning. The soft key toggles the HSI source. So we just saw that between nav1, nav2, and GPS. In the GPS mode, the HSI displays the track related to the active leg. Automatic sequencing occurs when passing over our active waypoints in our flight plan. So if we have it set to go from Piqua to Dayton VOR to Dayton, as soon as we get to Piqua, then it automatically switches, and then the GPS will move automatically for us. We don't need to reset it. The deviation scale depends on our phase of flight. We learned that earlier. There's the en route, the terminal, and the approach phases, and they will change for us. In the VFR world, we don't really focus on that too much. But to learn the en route, we have 5 nautical miles terminal, 1, and that's when we're within 30 miles of our airport. And then the approach sensitivity is 0.3. So what these mean is if I'm in the en route phase, here's the course that I want to be on. If I get 5 miles away, now my airplane's over here, then I'll see a full-scale deflection of the CDI bar. So then that lets you know, when you see the CDI bar, maybe you weren't paying attention, and we get a full-scale deflection en route, well then that means my course is 5 miles over to the right in this case, as I'm talking with my hands. Terminal, a full-scale deflection is 1 mile. So that CDI sensitivity, it changes depending on what phase we're in. Now, again, we're going to see a video. Right, GPS CDI. What we're talking about here is that right now I'm on the VOR CDI, so we have these green needles. What we do is we'll come down here to CDI. I want to change it to GPS, because right now I'm navigating direct to I-17 Piqua VOR. So we push this soft key down here, and now we see GPS. I'm in the en route mode, which is talking about the sensitivity. We know that en route is a 5 mile deviation would be full scale deflection. Then there's approach, and or terminal and approach, and that means that this becomes more sensitive. But for right now, what we're talking about is this is the GPS CDI. So I see it's in GPS mode, en route. It's talking about the sensitivity. And then where is it going? Well, we come up here, it's direct to I-17. One thing about the GPS CDI is it's going to automatically sequence. So we can go over here to flight plan, and I see in my flight plan here, it's going to go from I-17, my current point, to DQN to Dayton. Those are going to be the sequences that it follows. Okay, we're almost finished now. I'm going to finish with some airmanship and common errors. So, airmanship. When we're using the G1000, we need to train with a G1000 trainer as much as possible to know those basic steps by heart. So there's two ways you could do it. This is the CD that I downloaded that I'm using in this program, is the G1000 trainer from Garmin, and you could use that, or you could plug a GPU, ground power unit, into the plane, work with your flight school, and then push the buttons in the actual airplane. So that's the other way you could do it. But either way, you need to train these and understand them by heart. Very, very important. When navigating on GPS, always have a backup plan if the GPS fails in mind. We can turn radio aids in your vicinity to quickly regain positional awareness if your GPS fails. Pretty common topic when we talk about modern navigation and use of GPS. It's very reliable, but we need to have a backup plan, and it's just sort of situational awareness and thinking about it. Okay, on my route of flight, I'm going GPS direct, but I know, hey, there's a VOR over here to the left of my course. That could be just enough to know that it's there, have a chart available so that way you could tune that frequency if you need it. Those are some of the errors that we'll see when it's not working properly. We see we lost all of our numbers around here, and then we see that integrity message, as well as the CDI is missing. When receiving G1000 warnings, immediately resume conventional navigation until the problem's solved. Okay, very important, because this thing happens, bang, now we need to immediately transition to our conventional, whether it's using our outside visual references. Oh, okay, hey, I know where I'm at, there's that mountain, it's correlated on my chart, we're good. Now we could sort of begin to troubleshoot what's going on. And it's important to do that, immediately transition to our conventional, so that way we don't continue to fly and then maybe now we're heading in the wrong direction. That's sort of how things start to spiral out of control. So we'll immediately switch to conventionals. Then we can diagnose our problem. All right, if planning to use GPS as our primary source, thorough pre-flight planning is required. RAIM availability cannot always be guaranteed during some periods and in some areas. Thinking mountainous terrains and valleys. So those could be situations we get ourselves into that will cause RAIM problems. Common errors. Incorrect use of our cursor and rotary knobs. This comes back to that first part of airmanship where we need to train and understand our buttonology. So get that practice in so you understand. Otherwise things can get a little messy, and then we could do things that we don't mean to. So how to correct for incorrect button usage is to get practice and to think about it a little bit. Sometimes we get a little excited and just start pushing buttons randomly. That doesn't make sense. We need to have a plan and a systematic way of doing things, and that's how you're going to master this GPS. Know the functions of the inner and outer rotary knobs, enter, clear, and the push to cursor buttons. It's an extension of the same thing. Being unfamiliar with frequency auto-tuning, not expecting it or not checking that the frequency has been auto-tuned when loading an approach. That's for the IFR world. We don't see that with VFR, but we're talking about the auto-tune feature. When we load an approach, bing, the frequency is put in the standby, or it's auto-tuned. for us, when we're in the VFR world, when we're navigating, I tune in a VOR frequency, I activate it, it comes over. If we're within range, it'll auto ID, and in that case we'll see the 3-letter identifier of the VOR right there. So that's going to be a positive identification of the VOR. Now we can use it for navigation. Hey, that's it for this presentation. VFR GPS. Hope you learned a lot. See you on the next one. Hey, hope you receive value from watching this video. If you'd like to learn more from me, I invite you to take advantage of a free 14-day trial of FltLabs mastery programs. And inside, you're going to learn how to take control of your training, elevate your flying skill, and experience a new level of confidence in the cockpit. So, link for that's in the description below. Check it out, and I'll see you on the next video. See ya!